Hello, welcome back to my course. So last time we were able to run the Java program and be able to output something. So that is a necessary step to actually move on and actually do all the exercises in this course. We have to be able to run the Java program. So we were able to run this method with this statement, printline statement, and what the printline statement did was it printed out whatever is inside the quotes, which is hello world exclamation point. Let's go ahead and run that again by clicking the green button on the left. And there we go, hello world. So let's go ahead and move on to talking about what the lesson is about today. The lesson today will be about primitive types. And before we actually start coding anything, I want to go ahead and talk about it and read about it. So let's go ahead and go to this link here. And here we are. So this link is this documentation about our topic, which is primitive data types. And it goes over the 8 types of primitive types. There's 8 different primitive types. And before we actually dive in and talk about this, let's talk about what Java is. So Java is an object-oriented programming language. And what that means is that everything in Java is represented as an object, like a car object or a pizza object or an animal object or whatever, right? It just has a real-life representation of it. Except for these primitive data types, which we'll be talking about today. These are the only exceptions to this rule. Everything else is an object except these 8 types. And they are used to store numbers or true or false or characters like A, B, or C, or D. And there are 4 of these that store integers: a byte, a short, an int, and a long. And the reason why there's 4 different integer types is because they all hold a different set of values, different range of values. For example, a byte can only go up to 127 and go as low as negative 128, but a int, for example, can go all the way to 2 billion something, 2 to the 31 minus 1, and has a minimum value of negative 2 to the 31. While a long can go way, way above that. It goes all the way to 2 to the 63 minus 1, and has a minimum value of negative 2 to 63. But there's a trade-off of using a long over a byte, for example, because it can hold such a large value, it takes up more space in memory in Java because it holds more values, it holds more integers, it holds more numbers. So it takes up more space. So a byte is very useful when we're trying to save memory. We'll talk about this more in detail later, but the gist of it is that you'll most likely never use a long for most use cases. Like a use case for a long would be like the population of everybody on Earth, right? Like it's like in the billions, way above 2 billion. It's like I think 7 or 9 billion, I forget what it was. But you would use a long for that, while you would use like a byte for like storing information in a packet, which is like a networking, like very low level stuff, like just trying to save space. So it has its uses just like a long has its uses. But most of the time you'll be using an int. A short is also like similar to a byte, where it's used when you're trying to save memory. But like I said, usually we'll use an int because it's kind of like the sweet spot where it doesn't take up too much memory. For most use cases, and it also can hold a lot, like a very large range of numbers. It can hold up to 2 billion something and negative 2 billion something. That's the range. Now, there are 4 different other data types, and 2 of them are decimals, a long and a float. Just like, how some integers data types, like they hold more values. Same thing for a float and a double, where a double is more precise than a float, as in it can hold more decimals than a float. And finally, we have the Boolean, which can only hold true or false. and a char, which holds like characters like A, B, C, D, E, whatever to hold that alphabet, like either uppercase or lowercase. And finally, let's talk about the default values for each data type. A byte, a short, an int, and a long will all have a default value of 0. Now you see that a long has a default value of 0L, while I signify that it's a long. So L is for long, just like for float, 0.0F, F is for float. And the reason why we have 0 capital L is because a lowercase l looks like a 1, so you can actually use either one, but you'll have like your program, your IntelliJ program complain to you that it looks like a 1, so please change it to capital L if you do assign a long variable. Finally, we have string or any object, which has default value of null. And what null means is that it doesn't actually have a value. Null means basically empty or void or just empty, like it doesn't have a value. And we have a boolean, which default value is false. So those are the different default values for each data type. Let's go ahead and start coding this out and having more concrete, like real-world examples of these primitive data types. So let's go back to main.java and let's get rid of the system.out.println that prints out hello world. And let's just start from scratch. So let's talk about examples of integers. So we have int, number of wheels equals 4. And we can do a printline statement for that. Before we actually print it out, let's talk about how we assigned it. So the variable name is number of wheels, and as you noticed, the variable name starts with a lowercase n, and every other word starts with a capital. So the standard, this is called camel case. So when you declare variable names, you want to, most of the time you want to use camel case. Now, there are exceptions to that when you have, for example, a constant variable, like, for example, double pi equals 3.1459. Like, for example, if you're reusing this variable in a formula across your whole code, you want to make uppercase to signify that it's being reused everywhere in your code. Now let's go back to insto. So the data type is on the left-hand side of the variable name. So we have number of wheels as the variable name, and then the data type is on the left-hand side. So you can't put the int after the variable name. It has to be before variable name. So that's how the compiler, which is what reads Java code and so that it can be built, that's how it reads it. It reads it left to right, and it has a strict guideline. And also, like, int can't be capital int. It has to be lowercase. He says cannot resolve the symbol int. So it has to be lowercase, all lowercase. The Java is very case sensitive. And now, like I said, this variable name can actually be anything. It could be like number of wheels. It's not case sensitive, but we want to have good coding practice. We want clean code, readable code, and we use camel case for most variable declarations. Finally, we have the assignment of the variable. We say number of wheels equals 4. So basically we're saying that this variable points to the value 4. So it's assigned a value of 4. So if you actually go ahead and print out what this value has, so we take this variable name and put it inside println. When we run this program, then we should get an output of 4. And we do. Voila. Okay. So let's move on to the next topic of our primitive data types. And let's talk about doubles. Or actually switch it up first and declare a new int, which will be let's talk about pizza in this, for all these examples. It makes it very easy to kind of give like real life kind of meanings and examples to these variables. So for example, number of slices. So we, instead of number of wheels, let's just change this to number of slices. So number of pizza slices. So we say we have 4 slices, and we want to calculate the cost, right? So we say double cost per slice equals $2.50. Now again, double is case sensitive. It can't be like capital D, and it can't have any capital letters at all. It's all lowercase. Again, we use camel case for a variable declaration name, and after we assign the value after the equal sign. And oh, by the way, every statement, this is called a statement when you're signing, like most lines in Java are statements. Now, for example, this is not a statement. This is a method signature. This is a statement. This is a statement. Okay, so if it ends with a semicolon, it's actually a statement. So we have to add a semicolon at the end of each statement. For example, if we don't, we'll get an error. It says, sorry, just hover over. It says semicolon expected. So we have to type that in after each statement. Okay, so let's move on. So we have number of slices equals 4. We have cost per slice equals $2.50. So 250 times 4 is 10. So we say double total cost equals number of slices times cost per slice. So we can actually reassign, like in the right hand side, we can actually assign variables. So instead of saying like 4 times 250, we can say that number of slices equals 4, so we can replace the 4 number of slices, and cost per slice will replace the 250. So we can actually create variables that have values of other variables. And if we print out the total cost, we say total cost. So this is like a string, which is actually an object. We'll talk about this later, but so just like we print out hello world, we're printing out total cost here, but we also want to print out a value of total cost. So we say total cost, and this is not the variable name, this is just a string. It could be anything in here. It could be total cost, blah, 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 right? So we don't have to actually say like total cost camel case in the quotes. We can say total cost like English, like in a sentence ish phrase where you have capital T and then lowercase c, right? So it doesn't have to be camel case. It could be anything. It could be lowercase t, whatever. But total cost, we'll do colon, give a little, formatting. You say plus total cost. So this is actually converting this double to a string. So you're actually like appending to a string. You're saying that the string equals total cost plus a double value. So this is actually all going to be a string now, but it doesn't matter. What matters is that we should get an output of total cost colon space 10, because 2.5 times 4 equals 10. So while this is building, let's see, parsing Java. Yep, there it is. So the total cost is actually not 10, it's 10.0 because it's a double and it's a decimal value, right? So it's not 10, it's 10.0. So as you can see, we have two variables here. We have an int data type and a double data type. One is a integer, one is a decimal, and we multiply each one and save it to another variable, and we print out that variable. And it's a lot taken at once, but this is how variable declaration works in Java, and this is also how we declare primitive data types. We have to declare their type on the left-hand side before the variable name, and then the variable value either on the right-hand side, or we can reassign it later. For example, if you want to say double cost per slice, statement 1, semicolon, and we want to say cost per slice equals 2.5, cost per slice has a default value of 0.0, as we knew from the documentation. So right now it's 0, and now we replaced it with 2.50. So we reassigned the value to 2.50 because the default value is 0 at this point. And at line 9, it changes to 2.50. Now, if we try to print out or just save the total cost equal to number of slices times cost per slice, we get an error. And by the way, you'll see errors with red lines underneath where the error is. As you can see here, we have an error underneath cost per slice, and it says variable cost per slice might have not been initialized. And what this means is that even though that it has default value, it reads primitive type just like it would objects, and objects were not initialized as we saw before, or null. So it treats everything the same in terms of initialization, even though it has default value of 0, and it is initialized technically as 0.0, it still throws this error. So it basically, you have to assign a value to every variable, whether it's on the same line or the next line, because eventually if you want to use that variable somewhere else, the Java compiler needs to know what its value it is before it tries to process something else. For example, it's trying to process total cost assignment, value assignment, and it doesn't know what the cost per slice is unless you give it a value like it did here. So now the error goes away because I assigned it a value. So that's the way you can declare a variable and then assign it a value at a different line. So let's talk about other data types other than integers and decimals. Let's talk about booleans, right? Like for example, boolean hungry equals true. So am I hungry? I am hungry. So I assign it to true. And if I print out hungry and run it, I should get an output in the console of true. There we go, true. So obviously it's not useful, or just printing out the value, but I'm just showing you how it works, and we'll have more complicated logic later on in this course. So the final one I want to talk about is car, which is just a character. So like I said, it could be uppercase, lowercase. So like car, let's say pizza topping equals H for ham, and you see there's an error here because it cannot resolve the symbol hungry because we deleted that variable. It's gone, so it can't find it. So let's go ahead and replace that with a valid variable, which is pizza topping. And so H equals ham. Wait a second, what are these backslashes or slashes? Sorry. These are comments in Java, so they're not actually compiled in the Java compiler. So Java compiles that this is a valid statement, but everything after semicolon, for example, if you put like a no comment, is invalid. But if you put a comment, it's valid because the Java compiler just ignores everything that starts with a double slash, or ignores everything that starts with a slash star for a multi-line comment. For example, line 1, line 2, and so forth, right? So you can have multi-line comments. They're useful for documentation and documenting your code, saying like what the code actually does, or if you have confusing logic that is necessary, you can kind of explain it with a comment and say, oh, by the way, the reason I did this is blah. So comments are very useful. Some people put their names on top of the class. They say created by Carl, date, whatever today is, I don't know. Doesn't matter. Every day is the same. Anyways, pizza topping equals H got printed out in the console. So as you can see, we can print out anything really. We can print out any valid variable. So we can print out, but we can't print out an uninitialized variable. For example, if we try to print out pizza topping, now we get an error because same as before. It says it might not have been initialized because the default value is that weird value we saw before, which is 0 as decimal, but it can't figure out if it's been initialized or not because there is no assignment to this variable. It's not assigned a value like equals h, means it's assigned a value. Now it's assigned a value. Now it works again. That's basically it for primitive types. See you in the next lecture.